So now we're going to work the other way. They're going to give us the graph, and we have to come up with the equation for the rational function. So we're going to do, look for those same pieces of information that we were using to graph it. Now, what I usually like to do is look at the asymptotes first. So I see that there's kind of an asymptote right here at x equals -1. That's a vertical asymptote. And I have another vertical asymptote, it looks like at 2. And so when I'm setting up my equation, I'm going to say, well, f of x equals, and my vertical asymptotes, if you remember, they come from the denominator. So I'm going to have a factor of x plus 1, and I'm going to have a factor of x minus 2. Now, we're going to go for a function, we're going to say it's of least degree. So I see here that my graph, as it approaches the vertical asymptote -1, one's going up and the other's going down. So I'm on an odd exponent. Now that could be 5 or 3 or something like that, but I'm going to say it's 1. So I'm going to go for a least degree. So what I'm saying is there's an exponent of 1 here. Now I don't really need to write the 1, but I did. Okay. Now for where x equals 2, we see that they're going in the same direction. And so I've got to have at least a square there. Granted, it could be a 4 or 6 or something, but I'm going to go with the least degree. Okay, what other pieces of the graph do I know? Well, I know that there's an x-intercept at -2 and there's an x-intercept at 3. Also, they're crossing, but let me go with the x-intercepts first. So I have one factor of x plus 2. Remember, the x-intercepts are going to come from the numerator. And then I'm going to have an x minus 3 factor. Now, both of those will have exponents of 1 because it's crossing. It's not flattening and it's not bouncing. So those are both going to have degree 1. So I'm kind of close to being done. The only thing I haven't used is I also know the y-intercept. And I know the y-intercept is 0, -2. Now, what I have to consider is there could be some factor of a in here, something that I don't know, some constant that I'm not recognizing. And so I have to put that in and consider that, and I have to solve for it. But I can do that because I know the y-intercept. So because I know the y-intercept, I can say f of 0 is equal to a, whatever that is, 0 plus 2, 0 minus 3, over 0 plus 1, and 0 minus 2 squared. So then when I figure that out, I know f of 0 is -2. I don't know what a is. In the numerator, I'm going to get a -6. In the denominator, I'm going to get 1 times 4. So I get something like that. That's kind of messy, but I'll fix it. -2 equals -3 over 2a. So if I multiply both sides by -2/3, and those are going to cancel out, and I'm going to get 4/3 for a. Now here's how we're going to write that. So I'm taking this, which had everything but the a. So I'm going to put f of x, and you remember that a was 4/3. So what we're going to do is we're just going to put the 4 in the numerator. And we'll put the 3 in the denominator. And so that's our rational function. Now, you could multiply those binomials out to get polynomials in standard form for both the numerator and the denominator. I wouldn't bother doing that, but you could do that. Okay, so looks pretty good.